Okay, question 6. The discrete random variable x has the probability distribution below. Find the value of a and calculate the expected value and the variance of x. Okay, we need an extra column for the sum and we need a few more rows. First, we're going to need to multiply each possible outcome by its probability, and then to find variance, we'll need to decide if we want to use formula 1 or formula 2. Looking at the x values, they're whole numbers, and so it's probably going to be easier to use formula 2, where I need to square each of these. But we'll have a look and wait to decide. We'll see what the expected value is and whether it looks easy to subtract each of these from and square those, or whether we just want to square it once and take it off at the end. Alright, so first step, well, we need to find the value of a before we go any further. So we need to add these up, and they should always equal 1, remember? So when you do that, you'll find you've got 0.3, 0.1, that's 0.4, 0.5, 0.6, we've got 0.75, and that means that a must be 0.25, and I can write that in there. Next step, we need to multiply each possible score by its probability. So 5 lots of 0.25, 6 lots of 0.1, 7 lots of 0.15, and 8 lots of 0.2. And then if we add those up, that will give us the expected value, and we've got what we get when we add those is 5.7. So this now is mu, or the expected value. So we've done the first two jobs, now we need to find variance. Now 5.7, if I subtract that from each of these scores, I'm going to get an awkward number, 1.7, which I have to square, and that's quite complicated once I multiply it by more decimals. So although formula 1 would work, I think formula 2 is going to be much quicker. Let's square the scores and then multiply them by their probabilities and add those up, and then at the end we can subtract mu squared. Okay, so squaring each of these scores is quite simple. That's just times tables. And multiplying each of those numbers by the probabilities, 16 lots of 0.3, and I've got 25 times 0.25, which gives me 6.25, and I've got 36 times 0.1, that's easy, 49 times by 0.15 gives me 7.35, and the last one, 12.8. Now, when I add all of those together, I get 34.8. Now, what to do with them? Well, the formula that we're using says that we need to find the sum of all the x squareds multiplied by their probabilities. We've done that. That gives us 34.8. And then we need to subtract mu squared. Now, we know what mu is, it's 5.7, so we need to take off 5.7 squared, and you should get 2.31 as your variance.